Hi everyone. Good evening. Can you hear me? Okay, so great. Hope all of you are doing good. So let's start. Today we are going to see one topic which is called networking devices. I mean, what are the devices that we are using? So let's just see them in more detail. Okay. So suppose like this diagram I have taken from Crows. So basically there are a few networking devices that we have, and you might already be knowing. Just a second. But today we will just see in more detail, right? Okay. So like basically this idea is that how to connect two computers or maybe multiple computers, right? So most of the devices are just connecting multiple computers. That's all. Okay. So let's just see repeater hub which are working at the physical layer, which means that they do understand only the voltage, which means that they do not understand other than the voltage. They do not check the frames and all. So basically this repeater and hub both are at the physical layer. It means that they do not check the data, whether the data is is having some MAC address or what, right? So they do not have any of their table or something. So basically they just understand this repeater and hub, they just understand the physical voltage, right? Now we have bridge or switches. So basically these terms are very analogous. Either people say repeater or hub. Similarly, people either say bridge or switch. I mean, it is just that hub is having multiple ports generally, then the repeater, then we call it hub. Similarly, this switch is having multiple ports, then bridge, then we call it switch. Otherwise, these terms are very much exchangeable. So let's just see them in detail. Now, first is repeater. Okay. So repeater do not understand frames, packets, or headers. They understand the symbols that encode bits and bolts. So they only understand the bolts. A signal appearing on one cable is cleaned up, amplified, and put on the another cable. That's what this repeater does. So which means if two hosts are getting connected, then let's suppose this is repeater. Okay, this is repeater. It does only amplification. Okay, which means that if some signal is coming, let's suppose this signal is getting weak here, then it will restore the signal. Okay, so it will restore the signal. Has anyone used repeater at their home? Anyone? So like in ISC, what we used to do, I mean, there is a device called repeater. You can order it from Amazon. So we ordered from Amazon, and my room was at the first floor, and the friend with whom I was sharing the Wi-Fi, he was on the ground floor. So we were having some signal distortion problem. So that's why like I have installed repeater in my room so that my signal get restored. So repeater is one device that if you want, you can order from Amazon, and like it is very useful if your router is installed in one room, and in another room your Wi-Fi is not getting Wi-Fi signal is very weak, let's suppose. Then what you can do, you can just plug in that repeater. Very easy to install. Just it's a switch, or you just plug that switch in, and then this Wi-Fi signal get restored to the normal signal using the repeater. So basically, if this host is sending some data, and if the signal is getting low at this end, then repeater just restore the signal to this host. That's what repeater does. Regenerate the signal, right? Allow the communication across greater distance. So if you are having two hosts on the greater distance, then they can communicate using the repeater. That's what repeater does, right? But suppose there are multiple hosts, then what is the device that you can plug in? Generally, repeater has just two ports. Okay, but if you have multiple hosts, then you can put which device? You can put a hub. Okay, here you can put a hub. So which is same as repeater, it is just that it has multiple ports. In fact, like repeater, it is not necessary to have just two ports. It may have more ports also. It's not necessary to have just two ports. It is just that generally we use hub as a name when it is having higher ports than repeater. If it is having 2 ports, then hub is having maybe like 6 ports or 10 ports or something like this, right? If it is having if itself is having, let's suppose, 4 ports, then hub may be having even more ports. So it's not very strict definition that it is having just 2 ports. It's just that hub is generally having more ports. Okay. Yeah. So hub are simply multi-port repeaters, which means that they simply have more ports than the repeaters. That's the definition of hub. Okay. Now let's just see few of the points about the hub. So the hub has a number of input lines that it joins electrically. Again, there is no understanding of the frames or anything. It just understand the bits and voltages, these hubs and repeaters. Now frames arriving at any of these lines sent out to all the other lines, which means that if this is sending some data, it is a very dumb device, which means it doesn't check whether what is the MAC address or like, I mean, what is the MAC address that destination MAC address this packet is containing or anything else, right? It just forward it to in all the direction. It's very dumb device. Even though this packet is meant just for this, in this case also this hub just forward to every other port. Why? Because it doesn't understand the frame, right? It only understands bits and voltage. Okay. So frame arriving on any of the lines are sent on all others. If 2 frames arriving at the same, they will collide, right? If let's suppose this is sending to this, and this is sending to this only, which means let's suppose this is A, this is B, this is C, this is D. Suppose A is sending to D and B wants to send to C. In this case also, there will be a collision. Although like A can send to D and B can send to C without any collision if we use maybe some other device. But in this case, it seems like there will be a collision. Why? Because when A is sending to D, it's not just sending to D, it is sending to B and C also. So that's called collision domain also. So let me go to a definition that is called collision domain. Domain means number of nodes, basically. I mean, a set of nodes or number of nodes, basically, right? A collision domain is just a set of hosts or nodes which may collide. I mean, their packet may collide, right? So in this case, what is a collision domain in this hub? Since A is sending to D, then also the B, like it will be sending to B and C. So basically, this is one collision domain. This whole thing is one collision domain. Why? Because any of this packet can get collide. So that's why this is called complete collision domain, which means this hub is not reducing the collision domain. Okay, maybe if I use another device, maybe let's suppose switch, then maybe let's suppose, for example, a switch is intelligent enough to reduce the collision domain, which means if A is sending to D, then it should be able to send to D. Meanwhile, if B wants to send to C, it should be able to send to C without any collision. Suppose that device is switch, then switch is reducing the collision domain, right? So hub do not reduce the collision domain. Hubs do not reduce collision domain. Okay. Yes, they always do flooding. Okay. So hubs always do flooding, which means there is no intelligence here. Okay. Now let me just read the last point. Hub differ from the repeater in that they do not usually amplify the incoming signals. So basically, I mean, there are no very strict definition that what is the difference between hubs and repeater. This is the definition that I have copied from Crows. Okay. So this is the definition I've copied from Crows, but they are again saying that they do not usually amplify the signal, and they may amplify, may not amplify. Basically, it is just a multi-port repeaters, which means it is acting just like a repeater, which means it can amplify the signal also, and also it is having more ports. That's why I'm calling it multi-port repeaters. So this is from another standard reference, right? So anyway, like you can understand this hubs just like a multi-port repeaters, which is having more ports than the repeaters. That's all. Okay, but the difference are very slight. Again, they are saying the differences are very slight. Like the repeaters, hubs are the physical layer devices, do not examine the link layer address or use them in any way. So these are very dumb devices that do not examine the link layer address or the MAC address, and they do not use the MAC address in any way. Okay, So these hubs and repeaters are just like very dumb devices that just connect multiple hosts. Now there is one device that is called switch. So let's just see the switch. Hubs are simply multi-port devices facilitating the scaling communication between additional hosts, just like a repeater which connects two or more hosts probably, but hubs just connect more hosts than the repeater. Everyone receives everyone else data. This is very important, right? Everyone receives everyone else data. Okay, now let's see bridge. Bridge sits between the hub connected host, which means this is a hub which is connected to, let's suppose, these computers. This is a hub which is connected to, let's suppose, these computers, and there is a bridge that is connecting these two hubs. Okay, and bridge is little intelligent. Bridge can learn. Okay, I will tell you how it learns, but for now just understand that bridge can learn which host is on which side, which means let's suppose this is host A, this is host B, this is host C, maybe this is host P, this is Q, this is R. Now bridge can learn at least one thing, that okay, that ABC is on one side and PQR is on another side. How do we learn? It is very easy, how to learn. I will just tell you. Okay, but bridge is little intelligent. It means that it can at least examine the data link layer frame. So what will happen? Let's suppose A wants to send some data, okay, to maybe C or to maybe P. Let's suppose for this example, just for the case one's sake, let's suppose in the case one A is sending to C, which means it will send to hub, and then this hub will send everywhere, right? Because it is very dumb device, so it will send everywhere. Now in this case, this bridge, okay, suppose bridge initially do not know anything. Bridge is just like a hub, okay, at initial phase. So since bridge do not know anything, then what will happen? Will bridge stop this frame to go from here, or bridge will send this frame to go this part also? Tell me. If A wants to send to C, which means the destination MAC address is, let's suppose, C, then in this case, tell me what's going to happen. This A will send to this hub, and then obviously this hub will send everywhere because it's dumb device. Now this bridge will send to another part, this right hand part, or not? Or bridge knows that C is on the left area. What do you think? Okay, so yeah, not yet. Yes, that's correct. So basically bridge initially doesn't know that which is on which area, obviously. So when A is sending data to C, then it will send a frame, and this bridge is very dumb, like initially it is dumb, so it will also send to the next area. But how do we learn that that A and C are on the same side at least, right? How do we learn? No, bridge doesn't have network layer. So will it learn that C is on the side or something? No, it will only learn about A. Okay, based on the source MAC address, it will learn. So if source MAC address, the packet that is coming will be having, it doesn't care about the destination MAC address. It will say that, okay, source MAC is A. Then it will say, oh, it means that A must be on the left side. What about C? Maybe on the right side. It doesn't know, obviously, right? So it will say that, okay, let's suppose this is port number 1, this is port number 2. Okay, then it will say that, okay, this A is basically residing on port number 1. That's what this bridge will learn. These are called learning bridges. Okay, I mean, bridges are just learning bridges. I mean, people also call learning bridges. So basically based on source MAC address, bridges learns switching table or forwarding table, I mean, whatever you want to call. I'm just calling it bridge table. Okay, since it is bridge, I'm calling it bridge table. So based on the source address, it will learn. Now next time, let's suppose this C wants to send, or maybe B wants to send to A. Now suppose this is the scenario, and then B wants to send to A. Then what will happen? Tell me. Then this packet will come to this hub. Hub is dumb. It will forward to bridge. Now bridge will forward to this area or not? Since now in this case, bridge knows that A is on the left part only. That's why bridge will not forward, right? I mean, initially doesn't know, but after A sends some packet, then bridge will get to know. Okay. And this is the case when A is sending to C. Suppose A is sending to P, or maybe let's suppose P is sending to A or something like this. If P is sending to A, bridge will learn that, okay, P is on the port 2, like that, based on the source, right? So it will get to know based on the source. That is all. Now, maybe let's do one question. Okay. So let's do this question. I hope that is visible to everyone. Now, what they are saying is that consider the extended LAN. Extended LAN means there is one LAN and that is getting extended using bridges or switches. Okay. So this LAN may be having any topology, and then I'm connecting two lines using the bridges. I will clarify what is subnet, what is LAN. Okay, what is the difference between subnet and LAN? Just maybe after a few slides. Okay, I will clarify that what is a subnet, what is a LAN, what is a network, like that, right? So currently just think that there is a LAN, this is a LAN, this is another LAN, and there is a bridge in between that is connecting these two lines. Assuming all bridges are just turned on, so no frames has been sent. So initially there is no learning between these bridges, which means this bridge doesn't know that A is on, A is on this side or what, right? I mean, this is the port number 1. Let's suppose this is the port number 2. Then this B3 doesn't know that where is A, where is B, something like this, right? Okay. So what is the doubt? So to decide forward or not forward, it will use a destination MAC address, and to learn, yes, it will, yeah, that is right. So it will learn based on the source MAC address, and the next time based on the destination MAC address, it will decide that where to forward, right? So initially they are saying that there is no learning, which means bridge has just turned on. Okay, you just turned on these bridges. Now what they're asking is that this. Just a second. So basically they're asking few questions. Now they're saying that can you apply the spanning tree protocol, and then can you tell that which of the which of the ports are never being used, or maybe which of the ports are blocked. That's what this first question is asking. Indicate on the figure which ports, right? Which ports will be turned off in the final spanning tree. So can you do this question based on the previous video? So basically based on the previous session, I think you can just do, okay, this B1, maybe you can say this B1 is the root bridge and something like this, and then you can find the root port for every bridge, and then you can find the designated port for every line. That's how you can solve this question. Answer is on the next page, but yeah, you can try this. Now let's see this question number B, which is interest of today. So what they're saying, suppose the following frames are sent in order indicated, which means the A is sending a frame to L. Okay, A is sending some frame to L, right? So from here to here, maybe A is sending some frame to L, and then after that S sends some frame to A and M sends some frame to H. So they are saying what are the recipients. If A is sending some frame to L, then who receives? I mean, they are talking about in terms of host, that who is receiving. If A is sending some frame, then obviously it will send to this entire line. So C will receive. This will send to this B3. It doesn't know that where is the frame. So I mean, where is this L? It will send to entire this. It will send to this B4. I think that everyone will receive, right? I mean, like, since initially we do not know. So the answer of this question is that if A is sending some message to L, then who is the recipients? All, right? Everyone. Okay. Now let's do the next question, which is saying H sends a message to A. After the A is sending message to L, okay, after A is sending message to L, now H is sending message to A. H is sending message to A. Okay. Now who is receiving this packet? Now see, now everyone knows that where is A, right? I mean, the packet is coming from which way? Based on that, they will get to know that where is A. Once A sends a frame to L. So this B3 knows that A is here. B4 knows that, okay, A is here, right? A is here. B3 knows A is here. Something like this, right? Every bridge, this will know that, okay, A is here. Okay, maybe it depends that on the shortest path. If it is coming directly from B4, then it will get to know that A is here, or maybe A is here. It depends on the path on which the frame is traveling, right? So suppose that A is here, it get to know. it get to know that, okay, age here, age basically connected to this port. Suppose it get to know that age here, right? It get to know age here, something like that, right? You will, I mean, everyone will get to know where is it. Just a second, let me just copy this so that the diagram doesn't look very bad after the annotation. So I have just copied it. Now age here, right? Age here, it will forward. So for this age here, for this age here, for this age here, for this age here, suppose this is the case, right? Now when H is sending to A, when H is sending to A, where is H? H is sending to A. Now tell me who will receive. Now will B7 forward in this port? Will B7 forward on this non-highlighted port? Obviously no, right? Because B7 knows that age here, right? Age here on this port. So D and D will receive, and then this B4 will not forward here, right? D and D will receive, then B4 will not forward here, and then C and A will receive, right? C. I think D, E, C, A should be the answer. Let me know if that is okay to everyone. When H is forwarding to A, then this B7 will not forward to this port because it knows that A is not on this port, and then yeah. So and then this B4 will forward here. So I think DCEA should be the answer. A, C, D, E, and H. Okay. Yeah, if H is sending a message, so yeah, H itself is sending a message. Now, if M sends a message to H, if M sends a message to H after it, right? Now, in this case, see, this B7 will get to know that, okay, H is here. B7 will get to know that H is here. Right? And then this this packet has been reached here. B4 will get to know that, okay, H is here, and that is all right. Yes. So when S sends to A, will B3 learn about H? Yeah, I think B3 will also learn about H. Yes. So this, no, not the H, but yeah, to the H. Yes. So this B3 will also say, because this is just maybe the hub here. So this B3 will also learn about H. So yes. Now what is the next question? When M sends to H. So these are just for this color I am using for H. When M sends to H, then in this case, this let's suppose it is going through B9 or maybe B2. Okay. So I think that whether it is B9 or B2 will be based on the criteria that what is the designated bridge, right? So I think it will prefer the B2 because B2 must be the designated bridge if this is the root bridge. So first we will create the designated bridge. Yes, we need to do it because otherwise we can't be able to solve this question. So now this len, if M is forwarding to H, then I will send to B2 because the designated bridge is B2, right? B9 is not the designated bridge because if this is the root bridge, then this B2 must be the designated bridge, right? Because it is having the lower number, which is 2. Okay. So M is forwarding to H, right? So it will forward here. This B2 will forward. So N will receive. Now B2 doesn't know where is H, right? B2 doesn't know about it. So I think L will receive. Then it will forward to B1, and B1 will forward to B7. I mean this entire line, which is also connected to B9, and B9 doesn't know. So okay, so it will forward to this line, and now based on this line, like what is the designated bridge for this line? Because this line will be just forwarding to one of the bridge, either to B9 or B7. So what is the designated bridge? It is B1 only, right? For this line, at least it is B1 only. I think we need to do a first like a spanning tree algorithm. Then only we should be able to do this question. So let me just see the spanning tree answer that they have. B4 and B9 is blocked port. Okay. So one of the port of B4, I think maybe this port, and B9. Okay. Anyway, if M is forwarding to H, so we want to check if M is forwarding to H, then it will send to L, then this B1 will send to this line, and then this port is blocked or not. That's what I want to see, whether this port is blocked or this port is blocked. Okay. So let me see the answer. Maybe based on the spanning tree, then you should be doing this question. I'm directly concluding with the answer that which port is blocked. So JKLMNH, that's what they're saying. Let me see. If M is forwarding to H, then N L, that is okay. Okay. So it will get forwarded here also, JK. And yes, if it is coming to B4, then B4 will not forward to this traffic, right? Because B4 knows that H is on the right side, but it is not, the answer is not D. Maybe one of the port, maybe based on the spanning tree, we need to figure out that which port is blocked. I think maybe this port is blocked. So that's why this traffic is not getting forward, right? So maybe one of the port must be blocked. That's why this is the answer. We need to check with the spanning tree. Do you want me to solve this question first using the spanning tree? Or maybe you can do this as an homework. Just try the spanning tree first and then solve this question. Okay. Let me quickly know if you want me to solve this right away. Okay, I think you are also confused what to do. You can try it at homework. If there is any problem, you can ask me on the Telegram. Okay, just try it as a spanning tree. Just follow the spanning tree, and based on that, do this question. It is just nice question in the sense that it will get you more understand that how the bridges or the switches are working. Okay, so basically the switches or the bridges are just learning that where is the host based on the incoming packet. Okay, based on the source address. Great. So based on the source address, it learns that where is the particular host reside on, whether on this side or whether on this side, something like this. It is not very strict that bridge is having just 2 ports. It may be having multiple ports. Okay, but generally switches is just a higher version of it, which is having more ports than bridges. So again, there is no clear-cut difference between switch and bridges. It is just the interchangeable terms. Okay, people use switches more often. Okay, just like a term. So it is just like a multi-ports, but again, it is not very strict differentiation. That I mean, bridge may also be having the multiple ports. Okay, it is just the different names and the functionality is same. Learns which hosts are on each port. Okay, so it is also the same thing, which means it is also learned that okay, which host is on which port. It can also learn just like bridge or bridges and switches are both are the same thing. Okay, so what is the difference between bridge switch or the hub repeater? It is that it is not basically forwarding. If some packet is coming from here, then it is not forwarding to every of the port, right? If it knows that okay, this host resides here, it is just forwarding to one of the port, right? So switch forwards to one of the port only. Unlike hubs, right? Which means if this host wants to communicate to this, then they can easily communicate. Meanwhile, these two hosts can also easily communicate. So there is no problem in that, which means it is reducing the collision domain. How? Initially, if that's a hub, then the all of this side were forming a collision domain, because there might be a collision when any of this two is sending some data, right? So what is the collision domain? It is a set of host. Domain means set of host. in which if any two hosts are sending data, then it collides, right? So now tell me, if this entire thing is collision domain, can we say that if any two hosts are sending the data simultaneously, let's suppose it is sending a data, or maybe it is sending a data, then simultaneously, then they will definitely collide? No, right? I mean, if it is sending a data to probably this one, and it is sending a data to this one, then they will not collide, right? Yeah, obviously, if they are sending to each other, then they will collide. If they are sending to each other, right? Let's suppose this packet is here, and then this packet is here. I mean, on the way, then they will collide. But it is not necessary that they will always collide. There is no difference between bridge and switches. That's what I'm saying. It is just people say it is a multi-port bridge. Okay, there is no difference. Just like hubs and repeaters, there is no difference between hubs and repeaters. It is just a two different names. Similarly, there is no difference between bridge and switches, right? It is just that it is having multiple ports. That's all. I mean, that's also not very much a good differentiator. I mean, bridge can also have multiple ports. Okay. So here the collision domain is not this entire. Now, what is the collision domain here? Let's suppose that that there are two. Okay, let's suppose this is a switch or hub or switch or bridge, whatever. So this is one collision domain here, because if any of these two are sending the data, if any of these two are sending the data to anyone, right? Maybe R is sending to Q and P is sending to also Q or something like this. If any of the two are sending the data, or maybe this P is sending to Q and this R is sending to, let's suppose, C. If any of these two are sending the data, then there will be a collision, right? Because P is sending to Q, then also it will go in every direction, and then R is also sending to someone, then also it will be a problem. So there is a collision domain. Collision domain means a set of nodes in which if any two hosts send the data, then there is a possibility of collision. So now tell me, is there a possibility of collision? Yes, there is definitely possibility of collision in any of these two hosts, right? But can you say the entire thing is a collision domain? The answer is no. Why? Because will they collide if let's suppose C is sending some data to maybe A and P is sending some data to R? No, this bridge will say that okay, just keep your packet here and keep your packets here. If C is sending some data to B and then P is sending some data to R, then they will not collide, right? Yes. So collision domain is basically just a single port. So number of ports. If bridge is having two ports, then you can say there are two collision domains, right? So here, yeah. So switch forward a packet to one port only. So collision domain, every port is a collision domain. Which means like within this port, whatever is happening, they will collide. Within this port, whatever is happening, they will collide. But it's not like that. If P is sending some data to A and A is sending some data, I mean, sorry, P is sending, let's suppose, some data to Q, and A is sending some data. If they are like interacting in between, then it is not necessary they will collide. In fact, they will not collide, right? So a collision domain is basically, as I said, it is a set of hosts in which if any two hosts are sending the data, then if any two hosts are sending the data, then those packets may collide. So okay, let me go here. See, if this is sending a data, then this is sending a data, then these packets will definitely collide. That's why these all are in just one collision domain, because if any of these two are sending data, they will collide, right? Now similarly, if any of these two sending a data, they will definitely collide, isn't it? If any of this two sending a data, they will definitely collide, because this if A is sending to anyone, right, doesn't matter, then it will definitely go to C, and if C is also sending, then they will collide. If any of these two are sending data, they will collide. But if this and this are sending data, will they definitely collide? Answer is no. Maybe they are interacting with in between. Yes, they may collide. I'm not saying they cannot collide, but will they definitely collide? Answer, like for this you will say no, right? So sending data, it you can say definitely set of hosts in which two hosts are sending data, it will definitely collide. Okay. So here in this switch, if these two are sending data, they will definitely collide. But if this and this is sending a data, then it is not necessary that they will collide, right? Okay. Now let's just see more about the switches, or maybe the same thing that I have written. So switch facilitate the communication within a network. That's very, very important, that there are no two networks, which means this is just one subnet, one network or something like this, right? It's not like there are two different networks or there may be multiple networks. So switches does not divide the network. Okay, which means that if this is broadcasting some packet, okay, so routers divide the network, that I will tell you in just few slides. But switches or any of the device which is like switch or hub or whatever we have studied till now, they do not divide the network. This whole thing is just one network. Okay, the moment you place the router, it will divide the network. So let me probably go to the router, or maybe before that we can solve one simple question. So in GATE 2005 they have asked this question: which of the following statement is false regarding a bridge? Bridge is a layer 2 device. Yes, it is a layer 2 device. See here, it is a layer 2 device, which means it is basically having a data link layer. It is a layer 2 device, bridge or switch. Okay. Bridge reduces the collision domain. Tell me, is it reducing the collision domain? Does bridge reduces the collision domain? So obviously yes, because here there are two collision domains. One is this, another one is this. Yes. So it is reducing the bridge is used to connect two or more lines. Yes, it is also true. Like if there are two or more lines, you can use the bridge, something like this, right? Bridge reduces the broadcast domain. Broadcast domain means that a set of nodes, whenever you are broadcasting, then to whom you are broadcasting, basically, which means if this is broadcasting, then uh, then all set of nodes that it is broadcasting comes under the broadcast domain. Now tell me, if it is broadcasting, then which are all set of nodes that it is broadcasting, basically? If it is one network, then broadcast always happens in within the network, right? So this switch, if it is a broadcast packet, then this switch will actually forward to everyone. So broadcast domain is a set of nodes. Let me just write it. Which receives a broadcast packet if any of the node broadcast. Okay. So if anyone is broadcasting, then they will receive the broadcast packet. That set is called the broadcast domain. Suppose that these are the hosts that are in broadcast domain. Then let's suppose this is H1, H2, H3, H4, H5. Then what does this mean? If H1 is broadcasting, that must get to H2, H3, H4, and H5, and vice versa. Any of the host is broadcasting, that packet must reach to any other host. That's called the broadcast domain. Now, if this host is broadcasting, then will it reach to every host here? Then if the answer is yes, then yes, this whole thing is in the one broadcast domain. Okay. So tell me, if this is broadcasting, will it reach to every other packet? This switch does not bypass or does not stop the broadcast package, which means that if you are broadcasting, if this is broadcasting, then this switch just forward to every of the port. So in this case, so you will say that all of these nodes are under one broadcast domain only. Okay. So bridge reduces the broadcast domain. Then answer is no, it is not reducing the broadcast domain, which means that you are putting the bridge or you are putting the switch, actually both are same, right? You are putting the bridge or switch, then it is not reducing the broadcast domain, which means whatever is the broadcast domain earlier, maybe using the hub or something, right? And then if you replace this hub with the switch, then this broadcast domain is not reducing. But if you replace this hub with switch, then the collision domain is reducing, because now this switch is very intelligent. It will just forward to only one port. How we used to forward to every port, right? How we used to forward to every port, but switch is intelligent. Now switch will just forward to only one port. So that's why it is reducing the collision domain compared to hub. Okay, but it is not reducing the broadcast domain, which means if you're putting the switch, then let's suppose earlier that whole thing was one broadcast domain. Putting the switch does not reduce it. Now also this whole thing is just one broadcast domain. Okay, now let's see the router. Bridge and switches are not different. Bridge and switches both are same. See, bridge and switch are just different names. Okay, similarly hub and repeaters are just different names. Okay, so don't worry about these terms, you can use it interchangeably. Some people say that bridge is just multi-port, switch is just multi-port bridge. Similarly, hub is just multi-port repeater, something like this. But yeah, I mean, that's also not very standard definition. I mean, it depends on how, like maybe the author to author. I have not found this definition, to be honest. I have not found this definition to be consistent in every other place. Okay. So the definitions are not very consistent. Even in the books, they use it, I mean, interchangeably. So let's not worry about what is the difference between bridge and switch, because there is no difference. Or similarly, there is no difference between repeater and hub. Okay. Is this okay to everyone? Now, let's see the routers, right? Now, what is a router? Router is basically, let's suppose this is one switch, this is another switch. A router you are putting to connect two switches, right? Facilitate the communication between the networks, right? So basically, whenever you're putting the router, you will say this is one network or one subnet. Okay, this is another subnet or another network. There is no difference between subnetwork or network. So this is another subnet. So basically, the switches used to communicate within a network, right? This within term is important here. The switches, there is this entire thing is just one network, right? But if you put the router, then these are two different networks. Okay. In fact, this question has been asked in GATE 2022. Do anyone knows that this question has been asked in GATE 2022? How many subnets are there? Something like that. Okay. So we will see that concept. Let's just first see the router. It facilitates the communication between the networks, right? So suppose that you put a router, then it automatically becomes one network. It automatically becomes another network. A network is a grouping of hosts which requires similar connectivity. So maybe you can say, I mean, this is one network. I mean, it is up to you that why you are dividing. Maybe you want to have different departments in one university. Maybe it's a maths department, right? It is a CS department, and you want to have them in different networks. Maybe because of the it could be any of the reason. Maybe because of the security purpose. Maybe because of the maintenance purpose. I mean, if there are a smaller subnet, maybe you can maintain easily. Okay, for any purpose you can divide, right? It's not necessary that I mean, it depends on your usage basically, right? If you want to have different subnets, you can just put a router in between them. So provides a traffic control point, security, filtering, redirection. So basically here you can also filter like whatever is coming. I mean, based on, you can have some rules here. If the destination or if the source MAC address or the source IP address is this, then you should not forward that to here. Maybe some firewall you can put that or maybe if you want to, if this host wants to access some site that is restricted, then this router will not forward the packet, right? So maybe based on the destination IP address, you can stop the packet going to this internet maybe. Okay. So let's suppose this is the rest of the, I mean, internet means just a rest of bunch of the routers, right? So here you have just bunch of the routers which are connected to each other, which are providing you the facility of the internet, which means you can access any of the thing in the world. That's called the internet. So let's suppose this host wants to access some data that is restricted in the mesh department. Then this router will say that, okay, if you are coming from this particular port and then you are going to access this particular IP address or this particular maybe the router, then I will not allow. Or maybe similar set of rules you can put for the computer science department, right? Maybe it's different set of rules for math and computer science department. Can I differentiate between the set of rules? Yes, definitely. Router will say if that is the interface ID. So see, this is the network which is having 172.16.20.x, right? So now every interface will be having one IP address. Do you remember? I told you yesterday, every interface will be having one IP address. So here let's suppose this is slash 24. Now here there are 256 IP addresses. Out of 256, first one is network address, last one is broadcast address. In between, you can take any of the address, usually the second one, okay, or maybe the second last, and you take this address and you say that this is the interface address. So basically, this network just give one IP address to this router, okay, from its own set of IP addresses. So this network will give just one IP address. So let me write here. Every network gives one IP address to router from its set of addresses, right? Addresses. And that is also called interface ID. Okay. So which means every interface is having one IP address. Who is providing that IP address? That this network will provide from its set of addresses. It will provide one address to this router. Similarly, from this network, it will provide one address to this router. In the interface, we put only network ID. No. Interface is not network ID. There is first address is the network ID. Interface is maybe the second address, maybe any address. Generally, it is either the second address or maybe the second last address. Okay. Interface is not the network ID. Okay. So basically, this router is having one IP address based on this network. So this network will say this router is within me. I mean within my network. And what is the network ID? This is the network ID. And this network will say that this router is within my network. What is the network ID? This is the network ID. Like that. If let's suppose if this wants to communicate to the router, then it will be using some network ID, maybe the IP address, which is this network ID, right? It is not using the network ID address. So basically, network ID is different. Okay. So network ID is very much different, and the interface ID is very much different. Both are different. Generally, the interface ID is the second ID. Okay. And the network ID is the first ID, obviously, and generally the interface ID either the second ID or maybe the second last. I mean, like generally people do not prefer to give in between any address to this interface, because that will make little inconvenience to them, because then the set of IP addresses are not continuous for them. Okay. Yeah. So basically, this is one network, this is another network, and router is basically separating two networks. Now, probably let's just try this question, and then we will come to this router again. Okay. So let's suppose this is one switch. S means switch. This R means router. H means host. Okay. Suppose H2 wants to snoop all the communications from H1 and some other host. Okay. Let me just copy this question. Yeah, that ID you cannot give to host. Definitely. That ID you cannot give to host. If you are giving that to interface, you cannot give that to host. Okay. So what they want to say that suppose this is the configuration where this is a switch which is connecting these two hosts. This is router which is connected to this switch, and then there is a internet. Now this host is having some IP address, which is this, some subnet mask, which is this. Okay, this is a gateway. Gateway means that if you want to access the internet, then what is the first router I mean IP address of the first router. Okay, which means basically every network has one gateway. This is the first router that this packet will reach to. So this is the first router that this package will reach to. And if this is the interface ID, then the gateway is this one only, right? Gateway is this one only. See, gateway should be this one. Yes, the default router, you can say. I mean, basically it is the first router when you go outside this network. Okay, maybe it is an internet, or maybe this could also be some small network. Okay, maybe, I mean, internet is just all the network. I mean, internet is just all the networks that are connected together. Maybe it need not to be internet. Maybe it could be some small networks also. But if it is, let's suppose, connected to some router, which is connected to some router, and it is forming one internet, then you will say that the rest of the things is just internet. Internet is just a bunch of routers, right? Okay. Now, This is the default gateway. Okay, gateway address. Gateway is basically the first router that this host will reach to. Okay, host packet will reach to. Now, what they are saying? Suppose this H2 wants to snoop all the communication between H1 and some other host S. H1 and some other host S. Okay, so suppose that this is switch, and now suppose from like this switch is forwarding some packet to this H, and then H2 wants to listen that what switch this switch is forwarding. But as you know, that switch is intelligent enough, it may not forward to H2 until and unless it is a broadcast. So what they're saying that without disturbing the communication, H2 sets an interface to promiscuous mode, but alas, get at most one packet. Why? Okay, so I think this question is asking that if H2 wants to listen all the communication that is happening between S and H1, then H2 is, in that case also H2 is not able to listen. Why? Because this switch is intelligent enough. The moment this H1 is forwarding any packet to this switch will run that okay, okay, I mean this H1, let's suppose this H1 is forwarding some packet to anywhere in this internet. Okay, so H1 and some other host S. So suppose this H1 is forwarding some packet to this router. Now will this host H2 receive at first initially? Will this host H2 receive this packet? Will this switch forward this packet here also? Tell me. I think yes, right? Initially the switch doesn't know. So switch, if H1 is forwarding something to the switch, then switch doesn't know that where to forward, right? So switch will say that okay, let me forward it here also. So initially the switch doesn't know, but now it will learn that okay, H1 is on this side only. Okay, H1 is on this side only. Now if someone is replying, then will this switch forward to this side only, or it will forward to H2 also? Only just one side, right? So this H2 will listen just one packet. Why? Because the switch is doing the MAC learning. After the first frame is received from H1, okay, the first frame it received from the H1, it stop broadcasting frames where the destination address is H1, right? So if the destination address is H1, the moment it receives first from the H1, first frame from the H1, then it will stop all the frames that are designed to H1, and I mean to this port. It will only forward to just one port, only sending to just a right port. Is this okay to everyone? Even though H2 wants to listen, but H2 cannot listen all the packets, all the communication. Okay, that is coming to H1. Only the first frame, whenever H1 is forwarding, at that time it can listen, but apart from that, it cannot listen. Okay. It is very easy. Like, I mean, if whenever H1 is sending some packet, then this S will learn that okay, where is S1? And then if someone is sending to H1, in that case, since this switch knows that where is H1, it will not send to this interface or to this port. That's what they are saying. That because the switch is doing the MAC learning, after the first frame it received from the H1, the first frame is received from the H1, it will get to know where is H1. Now, whenever someone is sending to H1, it will not send to both the ports. It will just send to one of the port, which is the right port, this one only. Okay. So what is the next question? Describe what H2 can do on attack. So suppose that H2 wants to attack in this network, and then they are saying that what is the one kind of attack that H2 can do to force that the getting most packet from H1 to S. So H2 wants to do some attack, let's suppose. Okay, H2 wants to do some attack. Then they are saying that what H2 can do to force that whenever H1 is sending some packet outside, it will also get that packet, which means that this S is the H2 doesn't want S to learn something, right? Or maybe whenever someone is sending to this H1, then this S should send to both of the ports. It should not only send to H1. You're getting the question? At least the question is clear that this host should do something such that whenever someone is sending to this H1, in that case, this switch should forward to both of the ports. Okay, so this host doesn't want, this H2 doesn't want H to learn anything. So in that case, what H2 can do? So let me first know if the question is clear. I mean, we will see the solution, but is the question clear to everyone? Okay. So what do you think what this host can do? This host doesn't want this hash to learn anything, which means whenever someone is sending a packet, it wants that, okay, not only to this port, if someone is sending a packet to H1, like this host one, not only to this host also only, I should also get whatever this H1 is getting. Then what this host can do? Maybe just as an attack, what it can do, this S must be having some finite memory, right? I mean, it must be having some finite memory where it will say that H1 is on port number 1, something like this, right? Now, H1 means some MAC address is on the this MAC address is on this port number 1. Now, what this H2 can do? H2 can fake its own MAC address multiple times, which means H2 will say that, okay, I have some MAC address which is maybe h2.mac, and I'm on the port 2, right? H2 will send something to the switch, and then in this case switch will learn that, okay, H2 on this port. Now again H2 will send some other packet, and in this case the MAC address will be different, MAC2, something like this. It will say, okay, there is some other MAC address which is also on the port 2. There is some other MAC address which is also on the port 2. There is some other MAC address which is also on the port 2, something like this. This S will keep on remembering its own MAC address. Then eventually this memory will be full. I mean, this switch must be having some finite memory, and at some point in time, so basically there is always a timer. Okay, every entry has some timer, so after some timer this entry will get deleted. Now at that time, this host is basically asking the switch to remember its fake MAC addresses. Okay, it is saying I'm on port 2, I'm on port 2, I'm on port 2. Again and again it is changing the MAC address. It will say I'm on port 2, I'm on port 2, so that there is no enough space to remember this H1 MAC address, right? This is what it can do at most. So H2 can flood the switch with frames with 4 source MAC address, which means some fake MAC addresses it can send, and forcing H to evict H1's entry from its cache. This way, the next frame H1 will be broadcasted and H2 will get them. So basically, this switch will be having some fake MAC addresses, and it will say, okay, I'm on port 2, I'm on port 2, I'm on port 2, something like this. In this way, like, you will not be remembering the H1 MAC address. Okay. Yeah, I hope that is fine. Now, let's do one question where they're asking that given any router, okay, let's suppose this router is given to you, then they are saying that how many subnets are there. So number of subnets. If this is the router, then how many subnets are there? There are 3 subnets. One is this, another one is this, another one is this. So basically every router is connected to just one subnet. Okay, this is one interface ID. Maybe, I mean, you can give any ID. They have given this .1.4. Generally they give .1. I mean, just the next ID apart from the network ID, but you can give, as I said, you can give any one. So they have given this one, and then this is again network ID, some again interface ID. So these are the 3 interface ID, and these are the three subnets. So how to identify subnets? Router, whatever number of links a router is having, number of interfaces in the router is number of subnets. Number of interfaces equal to number of right. So let's just see this, that how to determine the number of subnets. Detach each interface from its host or the router. So basically this is an interface. Detach it from its router, creating islands of isolated network. So basically if you detach it, then there will be one network, this will be another network, this will be another network. So that's why there are 3 networks, right? Each one is called one subnet. Okay, so maybe let me go to next example. So suppose if I just ask you how many subnets are there, then what will you answer? See, there are three interfaces, 1, 2, 3. So 3 subnets, right? But this subnet is basically, since this interface is common, so you will not count it twice. Basically, this subnet is common. So which means this is one subnet, this is another subnet, this is another subnet, because these are the three interfaces. But these are just 3 more. Okay, you will not count it twice. You will not say this is one interface, you will this is one interface. Since this interface is common, so that's why you will say that this is one subnet, this is another, this is another. So that's why there are 6 total subnets, right? So how many subnets are there? There are 6 total subnets. The answer is 6, right? This image I have copied from Crows. You can find it on the Crows, or maybe any of the university. I have copied from Toronto. This is very reputed university, Toronto University. So I've copied from this Toronto University, or maybe like actually that concept is given in the Crows. Okay, so you can go to the Crows also. So let's just maybe do this question also. Now here, how many subnets are there? Number of subnets. Just a second. See, there is only one router. How many interfaces? 1, 2, 3. 3 interfaces. That's why 3 subnets. Yes. Right. Okay. So again, this figure is by Crows and Ross. So you can do this question as a homework. Like there are different routers that they have placed, and then they're asking the subnets. 1, 2, 3 routers, right? This is one LAN which is using Ethernet. This is another LAN which is using again Ethernet. Now this could be a switch, like in between. This could be a switch or maybe the hub or anything, right? Okay. Yeah, each interface is one subnet. So you can try doing this question as a homework. This is an easy question. I think you should be able to do it. Okay. So this is about the networking devices, right? So we have covered these networking devices. Now there are many other networking devices which are called maybe layer 3 switches, or there are actually different again networking devices which are not very popular. So we are not going to see them, right? So these are just popular networking devices that we have covered. Now let's just start transport layer, because everything at the network layer has been finished. Now we will be starting the transport layer. Let me know if you have already completed the lectures that I uploaded for the transport layer. Okay, so let me just pull over those slides and let me just revise you that what we have already seen, right? Great. Yeah, timers I will teach in the live class. So by the way, can I create another session, because like I want to cover this transport layer in the new video basically. So I think it is better to create another session. Do you want to continue now, or should I take this class tomorrow if you have not watched any of the lecture? Because if I take it now, then maybe I will not be able to take tomorrow in the morning. Okay. So yeah, new session I'm going to create, but should I continue now or maybe tomorrow morning? Okay. Since you have you covered? Okay. So let me start a new session with the new link. Okay. Just a minute. I will send in the group.